All right, characteristic number 2. There it is. Again, we've already talked about this a little bit in our first example. The second thing that you look at after your non-permissible values is whether things have horizontal asymptotes or oblique asymptotes. And the key to seeing that is looking at the biggest degree in your whole function. Is the degree bigger on the top? Is the degree bigger on the bottom? Are the degrees the same? So here is an example where the degree is bigger on the bottom. If you ignore everything but the largest degree, this is sort of a shortcut to find asymptotes. If you ignore everything except the largest degree, our largest degree is 1. We have 1x on the bottom. How many of that one do we have on top? None. You can write none of them. What would that simplify to? 0. This one is going to have a horizontal asymptote at y equals 0. In fact, when we looked at group 3, where all of the degrees were bigger on the bottom than they were on the top, whenever that's the case, you will always have a horizontal asymptote at y equals 0. Again, the idea is if x gets really, really big, and that's what they have in the notation here, as the absolute value of x goes to infinity, meaning that x could be very big positive numbers or very big negative numbers, y gets closer to 0. Because as you divide negative 4 by a very huge number, you're going to get closer to 0. And so this graph has a horizontal asymptote at y equals 0. From characteristic number 1, can you see that negative 4 is a non-permissible value? And for this graph, that would mean that we would have a vertical asymptote at x equals negative 4. You would plug in some points and find those sections, and you'd be able to graph that. So let's look at what happens when you have the same degree on the top and the bottom. Now the textbook goes into a more complicated way of finding out what the horizontal asymptote is. I've told you before, if you just look at the highest degree, which is x, you have a 2x on the top. You have an x on the bottom. What does that simplify to? Y equals 2, and that will be your horizontal asymptote. So here's their complicated way of doing it. I'm okay if you do it the short way. You're going to find out that you have a horizontal asymptote at y equals 2. If we look at this one, does it have any non-permissible values? Yes, x can't equal 1. It doesn't simplify, so this one also would have had a vertical asymptote at x equals 1. So if the degree is bigger on the bottom, or if the degrees are the same, we get horizontal asymptotes. What happens when the degree is bigger on the top? So the last example that we're looking at is x squared over x plus 1. The degree is bigger on the top. And if I did that shortcut method that we did for the first two to find our horizontal asymptotes, you're going to see why this doesn't give you a horizontal asymptote. What's the highest power? What's the highest degree? It's the x squared. We have 1x squared on the top. How many x squareds do we have on the bottom? We don't have any. You can't divide by 0. It's not possible. So because that's not possible, you're not going to have a horizontal asymptote. When you don't have a horizontal asymptote, it's going to mean that you're going to get an oblique asymptote unless, as we saw in the first part, we had one where the degree was bigger on the top, but it was a hole, and it ended up just being a line with a hole in it. Okay? But if things don't cancel out, this one doesn't cancel out, there's no hole, what you're going to need to find is the equation of that oblique asymptote. And the way that you find the equation of your oblique asymptote is you actually divide using synthetic division or long division. So here, they've used synthetic division. Can you see that x squared would be 1x squared, 0 x's, and 0 numbers? And if you were dividing by x plus 1, synthetic division, you'd put the negative 1 out in front. You would bring down your 1, multiply, add, multiply, add. And so you would get y equals x minus 1, remainder 1. The equation of your oblique asymptote is right there. No matter how big or how small this remainder is. It could be remainder 1 billion, which would be a huge remainder. It wouldn't matter because that would be your asymptote. Now, the reason that that works, okay, if I wrote my division statement. So my division statement says polynomial equals dq plus r. So we started with x squared, we divided by x plus 1, we got x minus 1 as our answer, and we had a remainder of 1. This is what that would look like. Now we're trying to graph this, x squared over x plus 1. Can you see that I could get this on the left side if I divided by x plus 1? But if I divide that side by x plus 1, I would need to divide this side by x plus 1 as well, which would divide both of those things by x plus 1. What that would result in is x squared over x plus 1. Well, here they would cancel, so I would just get x minus 1 plus 1 over x plus 1. You get asymptotes, oblique asymptotes and horizontal asymptotes. They're there to show you what happens when x gets really, really big. And so in this case, when x gets really, really big, what happens to the right-hand side? This part is equal to 0. No matter how big that remainder was, even if this remainder up top was 1 billion, still when x gets huge, it's going to go to 0. And so that is why this becomes your oblique asymptote. Now you're not going to be asked to explain why something is an oblique asymptote. You're just going to be expected to be able to find it and graph it. So here's example 2. We're going to look at both of these. Again, it says just to tell whether it has a horizontal or oblique asymptote, we're going to go through the process of graphing it. So the first thing when graphing, always, you're going to factor. Well, I guess step 0 is factor. So I'm going to factor this first. The top factors nicely to be x plus 7, x minus 1. And the first thing we always look at is our non-permissible values. What can't x equal? X can't equal negative 2. Is that going to be a whole or a vertical asymptote? Nothing cancels out, so we'll have a vertical asymptote at x equals 2. Notation-wise, again, when we write non-permissible values, we put a line through the equal sign to say x can't equal that. When we write an asymptote, we always have an equal sign because we're writing the equation of that vertical line is x equals 2. Step 2, we look at whether we have horizontal asymptotes or oblique asymptotes. And we can do that. The shortcut is to quickly look at the highest degree. So the highest degree in this one, in the whole thing, is an x squared. So we have 1x squared in our numerator, but we have no x squareds on the bottom. Can you divide by 0? This is not possible. That's telling us we're going to have an oblique asymptote. So we have to use synthetic division set up my synthetic division here. I'm dividing by x plus 2, so I put a negative 2 outside. X squared plus 6x minus 7. So I bring down my 1, multiply, add, multiply, add. So our oblique asymptote will be at y equals x plus 4. That remainder of negative 15 won't make a difference. So when you go to graph, we know that we have a vertical asymptote at x equals 2. We have an oblique asymptote at y equals x plus 4. That has a slope of 1 and a y-intercept of 4. And this is what our asymptotes look like. That one goes up further that way, that one goes that way. Again, we have one vertical asymptote that separates our domain into two sections. We have our domain is x values less than 2, and our domain is x values bigger than 2. So now to get our final graph and to put it inside of these asymptotes, we're going to need to see if we can find some points. So an easy point is your y-intercept. If you look at your original equation and you plug in 0 for x, can you see that you'll get negative 3.5? Wow. You see the mistake I made? Nobody pointed it out? It's negative 2. You're just going to let me suffer? Okay. I just noticed that. 1, 2. It'll be here. There we go. Move that over. Add that negative. We would have noticed, sometimes you'll notice when you make an error like that, when you go to graph it, your points don't seem to work out, things don't fit, but hopefully we noticed them earlier. Well, we use negative 2 here in synthetic division because you're dividing by x plus 2. So one thing from chapter 1 that you'll have to remember from synthetic division is if you're dividing by x plus 2, we put the negative sign, opposite sign in there. Yes? Go back down here or back up here? The question before. Well, can we finish this one first and then go back to it? Okay. Did I make a mistake in the question before too? Oh, man. Okay, we'll have a look at it. So, we've got x equals negative 2. We just said if I plug in 0 for x, I'm going to get negative 7 over 2, which is negative 3.5. So I have a y-intercept right here at 0, negative 3.5. If I want to find my x-intercepts, my function nicely factored. Remember, an x-intercept is when you plug in 0 for y, and the only time that a fraction is ever equal to 0 is if the numerator is equal to 0. Since it's factored, when can the numerator equal 0? A negative 7 and 1. So if I go down and put those points on here, I would have 1, 0 and negative 7, 0. We technically have enough points to graph because we have some points to the right of our vertical asymptotes and some points to the left of our vertical asymptotes. So the last thing with those points in those sections, the last thing you would have to do is draw a nice smooth curve going towards your asymptotes in each of these sections. We almost need it expanded bigger to make it approach those asymptotes better, but this will be our final graph. Yes.
What's the 0, -0
That's our y-intercept. And our y-intercept we find by plugging in 0 for x. So I plugged in 0 for x into the equation. At any point, if you feel that you need more points, you can always plug more points into your equation and get a bigger table of values and more points. Part B. This is exactly the same, except things have been flipped around. So if we do step 0, which is factoring things completely, we get x plus 7 and x minus 1 this time on the bottom. Step 1, looking at our non-permissible values. Do we have any non-permissible values? Well, now x can't equal 1, and x can't equal -7. And those will both be vertical asymptotes. They'll both be vertical asymptotes because nothing's simplified. If something's simplified, you would get a hole or a point of discontinuity. But since nothing's simplified, you'll get vertical asymptotes. 2, this is when we're going to look at oblique asymptotes or horizontal asymptotes. Maybe you recognize right away, oh, the degree's bigger on the bottom. I know we have a horizontal asymptote at y equals 0. Maybe that's a characteristic that you're starting to memorize. But if we use the shortcut and say, well, what is the highest degree in this one? It's an x squared. I have an x squared in my denominator. I have no x squareds in my numerator. This simplifies to y equals 0, which is always the case. When your degree is bigger on the bottom, this will always happen. You'll always get a horizontal asymptote at y equals 0. So now when we go to graph this, we draw all of our asymptotes. So we have an asymptote at vertical asymptotes at x equals 1 and x equals -7. We have our horizontal asymptote at y equals 0. There we go. That looks better. Not very straight. None of those lines are very straight. And now when we go to graph this, what we're going to need to see is, well, it was easy to find x-intercepts and y-intercepts, so let's find those points first. And if I plug in 0 for x, can you see that you're going to get -2/7? So 1 point is 0, -2/7. If I want to find my x-intercepts, if there are any, you're going to have an x-intercept only when your numerator is equal to 0. Can you see that your numerator could be 0 at -2? Okay? And this is going to, for some of you, this is going to hurt. There's a point on an asymptote. Okay? Because in grade 11, your asymptotes that you dealt with were mainly vertical asymptotes. And vertical asymptotes deal with non-permissible values. So vertical asymptotes never have a point going through them, because that's a non-permissible value. It's just not allowed. But horizontal asymptotes, they're there to say what happens when x gets big and what happens when x gets big negatively. So extremes. And so it can happen, as it does in this case, that your graph goes through an asymptote in the middle, because a horizontal asymptote is not a non-permissible value. Yes? Like just have sort of parts of it, not have it in the middle? You could, but it's not it's a straight line. And when you label it as y equals 0, well, y equals 0 continues all the way through. It's a straight line. So now we've got these 2 points, and we don't have enough information to graph this completely. First of all, can you see that your vertical asymptotes have separated this into 3 sections? X less than -7, between -7 and 1, and x bigger than 1. So if we wanted to find out what happens when x is less than -7, well, we'd have to plug in a point. Maybe I would choose -8. If I plug -8 into my equation, what am I going to get? Well, on the top here, I would get -6. And on the bottom, I would get -1 times by -9. Can you see that that would simplify to -6 over 9, which is -2/3. So I have this point, -8, -2/3. It can't go through this asymptote again because we found our only x-intercept to be -2, 0. That was the only place the numerator was equal to 0. So we can't go through the x-axis again because that would create another x-intercept. And there's a non-permissible value there, so we have enough information to show it going towards our asymptotes. Okay? If I chose something in this section over here, picking a value bigger than 1, like 2. If I plug 2 into my equation, I would get 4 on the top, 9, and 1, which would be 4/9. So I can estimate where that would be. 2, 4/9. And again, I have enough information in this section to draw my graph towards the asymptotes. In the middle section, I don't quite have enough information. I have enough information here to say this needs to go down. But I don't know if it bounced off of my x-axis or if it goes straight through. So in order to figure that out, I might plug in a value, another value like -3 or -6. Right? If I chose -6, okay? Can you see that the top would be -4? -6 in here would give me 1, and this would give me -7. -4 over -7 would be 4/7. So I could plug that point in, -6, 4/7. And that's telling me that this needs to go up towards the asymptote as opposed to down towards the asymptote. Yes?
Why is the point 4/9 bigger than 4/7?
Why is the point 4/9 bigger than 4/7? Just because it's badly drawn. Not to scale. It depends on how badly to scale it is. Okay? With fractions, they're pretty lenient as long as I didn't mark 1 here and have 4/9 bigger than 1 and 4/7 bigger than 1. They're pretty good. And also, for the most part, when you have a graph to do, you either have a grid. On the final exam, they give you a grid to actually work on, so then you can be more accurate. Next year in your IB graphs, the grids are even crazier fancy, so you can be even more accurate. Okay, questions for this one are 6 and 7.